Hello, and welcome to Quantitative Reasoning Online. Today we'll be looking at 11D, Lesson 11D Preview Assignment. So let's see what that is. Let's be surprised. It's on hares and lynx. Wow. Rabbits and wild cats. I wonder how hares and lynx get along. The link to the hare. I'd love to take you home for dinner. Come on. Excellent. Okay, so what is today's objective? To read an academic article in graphs and identify key information. Okay, how to read a technical publication. Determine a formula for a jointly proportional variable. First, we have to figure what jointly proportional means. Determine the value of a jointly proportional variable. And determine how jointly proportional variables affect each other. All right. Sounds good. So, in the next class, you continue to study population growth decay. You need to understand proportionality and exponential growth, and you need to explore the concept of joint proportionality. The tutorial for the preview of Lesson 11, Part D, that'd be Stephanie's side of the house, using the workbook, Hares and Lynx, begins here. What's this area? So let's review the article. What drives a 10-year cycle of snowshoe hares? HTTP, yada yada, PDF. So copy. Open the window up, paste and go. And here we have the hare, the article. And it is a long one. Meine Güte. That's a lot of reading. So this is a technical academic article. Read at least the first couple of pages for general understanding and look at the first few graphs. So I'm going to assume you're going to put me on hold right now. You're going to quick rush out and open up 11D in a separate window, pull up this website, this article, and read the first 5 or so pages. So I'm going to go on pause for a few. I'm going to go on pause. You're going to go on pause and read it. The first 5 pages. I'm sure you read it. Let's go see what the questions have. So which of the following is the best description of the way the snowshoe hare population changes over time? The population increases faster and faster over the time. Population increases rapidly, then slows down, finally leveling off. Okay. So this guy is basically describing A. A is the exponential. B is the logistic, and C, well, roller coaster. Now you're going to look at the hare cycle. Here's a hare cycle, and density is blue, reproduction output. Well, looks like it goes up, goes down, goes up. Look at the lynx population, goes up, goes down, goes up, like a roller coaster. So, C, like a roller coaster. Again, way it's even tighter is the 10-year cycle. To have a cycle means you're going up, you're going down, going up. A cycle means you're repeating. That you're repeating some occurrences. Oop, gonna keep that. View the prompt. This pattern matches which type of growth? Linear growth? Oops, and of course linear. No. Exponential? Nope. Logistics? Nope. None of the above. I'd say it does none of the above because the curves, but not a straight line. Exponential goes up and up and up and up. Logistic starts low, goes up, levels off, and this guy does none of the above. So D, none of the above. Explanation: none of your growth model sketches should match the description of the snowshoe hare population is cyclical. That is correct. Okay, now let's see. Find the definition of jointly proportional on line and use it to answer the following question. In each case, assume that x and y are positive. So, go on pause and look up jointly proportional and what it means. So what'd you find? You should have found that jointly proportional is essentially a variable that is proportional in some way to two or more other variables. Or basically z, in this case, equals k, x, y, and you could have a z, a, and b, and c. It could be more than two. Yeah, wrong one. Typically, it's two though. So we have what we call a proportionality constant. Proportionality constant. Okay. So as x and y varies, there is a constant to which z is the output. So assume that z is jointly proportional to x and y, and that z equals 2. When x is 100 and y is 10, what is the formula for z in terms of x and y? Okay, so again we have z equals k x y. Given z equals 2 when x is 100 and y is 10. So 2 is k times 100 times 10. Divide both sides by 1,000, which is 1 over 500. Or, better yet, what we learned in the previous section. 2 over 1,000 means 2 times 0.001. Remember, 1 over 1,000 is 1,000ths. I have 2 of them, so k should be 2,000ths. So z should equal 0.002 xy. Yipper. Given the value of k from part A, find the value of z when x is 50 and y is 200. Okay. So z is 0.002 times 50 times 20, which is 0.002 times 1,000. So z equals 2. Same as before. Now wait a minute. So the same answer when x was 100 and y was 10. Got the same answer. That's interesting. So in this case, x went down, but y went up. So x was halved, y was doubled, and half times 2 is 1. So there's no net change overall then. Interesting. Okay, I clamp now. So if z is joint proportional x, z equals kxy, with a positive constant proportionality, that's k, will z increase or decrease if x increases and y increases? So z equals some constant, x gets bigger, y gets bigger. So I got two numbers getting bigger, I multiply them, which means z must also get bigger. Okay, if z is proportional to x and y, positive k, will z increase or decrease if x decreases and y decreases? So what would z do if x gets smaller and y gets smaller together? I think it's pretty easy to see that z must also get smaller or decrease. Okay, again, z is proportional, positive proportionality. What would z do? What would z do? K is a constant. If x increases and y decreases. Z will increase, z will decrease. We don't have enough information. Now we did have an example where this happened. Actually, what we had was x decreased, y increased. Earlier, we had a sample where x went down by a factor of 2, but y went up by a factor of 2, and z had no change. So I think it depends on, you need to know the magnitude of the changes. If x gets a lot smaller, say x went down by not a half but by a fourth, and y only doubled, then we're going to have an overall change by a half. Or if x went down by not much, say it was still 3/4 what it was, and this guy again doubles, so this guy was no change. This guy would reduce. This would be 3/2, which is greater than 1, so he'd go up. So unless we know what x and y is doing, we can't say. We don't have enough information. So let's see. Hey, we're done with this one already. That was a quick one. Let's see how we feel. How confident you are that you read an academic, that was a lot of too many syllables, academic article and graphs and identify key information. Depends on how bored I get. How confident you can determine a formula for a jointly proportional variable, i.e. find k. How confident are you that you can determine the value of a jointly proportional variable? If you know k, you know x and y, find z. And how confident are you that you can determine how jointly proportional variables affect each other? You know, what happens as x and y changes? That's pretty straightforward. Yeah. Uh-oh, lost my light. So that'd be all. That's it for this one. Did we do everything? Let's take a look. We read an article. Yes. We determined we found k. We found z varying x and y with a constant k. And we analyzed what happens if x and y changes in a proportional equation. Check, 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 and check. So we are done with the introductorial, and I'll see you. So go and look it over again. Read if you haven't yet thoroughly read the article, get the key information out of it, and I'll see you shortly later for question 1 and question 2.